All right, we're going to be talking regex, folks. And regex is short for regular expressions. And well, what does that mean? Expression could be, is a catch-all term. You've heard expressions in math, you've heard expressions in programming. Expressions just means either a value or an operation that produces a value, right? 1 + 1 is an expression, results in 2. 2 is also an expression. Some algebraic formula is an expression. Regular expression are how we have a tiny little language. It's almost like its own little mini programming language for dealing with text patterns and character patterns. So regular expressions, we can call regular expressions regex or regex patterns. These all mean the same thing. And it's basically a tiny little language. This concept of regular expressions is much larger than only Python. In fact, every modern programming language has some regular expression library, or it's built into the language itself. So what can we do, and what are we gonna do with regular expressions? Really, what we can do is check to see if a string matches a given pattern or matches a given other string, like a literal string or an algebraic pattern for strings, like repetition or a number of characters, that kind of thing. Is there a match for this pattern anywhere in the string? And then with our patterns, we can modify strings with a replace. We could split strings. Splitting strings is really powerful. That's how we turn one string into a list of strings. So we're going to use the RE, the regular expression library from Python. So you don't have to install this with pip. It's built into Python, but you still need to import it, just like the OS library or any other number of libraries, like the math library is part of Python, but you still import it. The 4 big methods that we're going to be working with are search, find all, split, and sub for substitution. Search scans through a string looking for any location where the pattern matches. You may see another method on the regular expression, or you will see another method on the regular expression library called match. Match and search are very similar. I'm going to suggest we stick with search because match just does the start of a string. And there's more elegant ways of doing that. I'll leave it to your imagination what find all does. And split allows us to generate whatever our pattern is. We could generate a list of strings out of breaking on that pattern. And we can substitute things. So regex is, bless you. Regex is a powerful tool. It's a tiny little language. The upside is power, a lot of power, and a lot of precision, like super duper laser precision. The cost of regex, however, is learning something new and exposing yourself to syntax that's kind of unfamiliar. Like you're going to see some weird characters in regex. And I think this is what a lot of folks think code is when they think about code. They think about funny characters. Like, and after this much time that y'all have spent with SQL and with Python, I mean, heck, y'all could read another programming language like R and figure out what's going on pretty easily because y'all have been learning programming language syntax. Regex is more special characters and they all have special meanings and context. So make sure you freshen your coffee over the break, right? The payoff, however, is this little mini language that you can, it's not 100% portable between every other language out there, but the basics are very similar between different languages. So regex is popular all over the world. And I'll tell you right now, if you roll into an outfit and you are the regex person, there's a little bit of job security rolled into that, right? It's not something everybody spends a lot of time with. And even folks that that do spend a lot of time with regex, they might not read and write it every day. Regex is very, very popular for command line tools and command line automation. Some system administrators just know a lot of regex for searching to find string patterns across configuration files or across text files. And regular expressions libraries, there's one in Python. All the different SQL flavors have their own regex. The Java languages like Scala, Java Enclosure, anything that runs on the JVM has a regex. C#, PHP, Julia, Ruby, all of the modern languages have regex, either built into the native language or part of the standard library, which is kick butt. So like SQL, and we've established that once you learn some SQL basics, if you roll into a Redshift environment or a Postgres environment, your basics are going to come with you. It's very similar with regex. The regex that Python uses is based on Perl's regex. Perl is a language kind of built around regex and text processing. And it has a lot in common with PHP regex too. I'm here to tell you, regex is not the right tool in 100% of the cases. So it's really, really powerful, but it's not, we don't want to use it every single time. If you can solve the problem with built-in string methods in your programming language, just use those. It's easier, it's more maintainable. Other developers won't curse your name for using regex for something that you could have just done with a built-in string method. And if you need more, which begs the question, when is regex the right tool? Well, regex is the right tool if you need to go beyond built-in string methods. Like the pandas.str has tons of string methods. Python has built-in string methods. If you need to go beyond those, regex is your new friend. And I'm going to emphasize this pretty strongly. This next piece, if you are working with HTML, JSON, or XML, regex is not your friend. I say this because our next lesson, we're going to be scraping HTML. And the adjacency, the closeness between these two lessons means that I've seen a lot of students try to do regex on HTML. That's a terrible idea. If you want to do just harm yourself, do regex on HTML because it's going to drive you bananas and it's already a solved problem, right? Just because there's so much weirdness in HTML, so many different funny little characters.
What about this? Well, yeah, I guess you're scraping it for strings. So what if you were trying to find like an instance where you want to find the capital and the lowercase?
Oh yeah. The text.
Use compile.
The text of the HTML. Yeah. But if we're talking about the code of HTML.
Oh yeah, exactly.
I caution y'all, and I will accept no questions about regex and HTML because it's like the first search you do on Stack Overflow says don't do this. So same thing with JSON, same thing with XML. Yeah, Kate, go ahead.
Yeah, question on the last section when you're talking about regex in different languages. I just want to make sure I understand, is regex slightly different? Can it be slightly different across languages? Is that what you're saying?
Yeah, it is slightly different between languages, yes.
But it's pretty similar, like maybe not.
Yeah, pretty similar. Like maybe the command line regex uses a different character for the same thing in some place, or maybe the syntax for counting number of characters is slightly different. I wish this could be, so these are kind of like Romance languages. The regex implementations in different languages, you should be able to at least find your way to the bodega, right? Does that track? Does that make sense?
Yeah, thanks.
But like if you memorize and get the Python regex syntax tattooed on yourself, and then you end up in a Julia environment or a Java environment, it's not going to track up one-to-one. It'll be close. They'll be cousins, but I wouldn't get it tattooed. Just because we're still in the infancy of a lot of these languages. Even Python being 22 years old, 23 years old. Julia's up and coming. C# and Java, like the world runs on Java and C# a lot. So Yeah, I wouldn't bake into one implementation. If you are parsing JSON, if you are parsing HTML, if you are parsing XML, use a tool that's built to parse those. And we'll do that once we scrape. We will use tools that parse that for us. Cool, great question. Great question, Kate. Any other questions on the big picture now? The what, the so what? Why should you care? If you missed this lesson and just totally space out, can you still do data science? Yes. Is this a really powerful tool to have? Even if the exercises might feel a little challenging here, they might start early and get more and more challenging. Can you still regex your way out of a wet paper bag if you can't do like the last exercise? Yes, right? This is all for your toolbox. And the NLP section is the best place to put it. Question, or you just? Okay, cool. All right. So now what? Now that we know regex is powerful and it has a lot of precision, what do we do? The easiest thing that we can use regex for is writing patterns to match literal characters, matching literals. And the thing that makes regex more feel like reading code is we have this concept of meta characters, and each meta character has a specific piece of functionality behind it. And here's what I mean. The following characters are regex meta characters: the period, the caret, dollar, asterisk, plus, question mark, curly braces, square braces, backslash, pipe, and parentheses. If you just put the letter A in a regex pattern, you'll find the letter A. But if you put the period character, it has a special use. Same thing with a dollar sign, parentheses, etc. So can we match those literal characters? Yes, but we have to escape them. We have to put a backslash in front of them. I'm going to go through all of these. We're going to have plenty of examples. This notebook has more examples than only the curriculum. So I hope you'll find this very useful. So we will go over all of these different characters. I'll give you the manifest of them in a minute. We also have this idea of a character class. And that's not the same thing as a character class in a role-playing game. A character class is a set of characters. So if we had a range of characters, a range of letters like A through Z, that we would put A-Z in the character class in the square brackets. The example, now you're going to see our strings start with R for regex patterns. That's not because R is for regex here. It's because R in a Python string stands for raw, a raw string, a raw Unicode string. Just like we have the letter F before a formatted string, and it changes how that string operates, the letter R changes the default string operations. Really, it has to do with escape characters and backslashes. I'm not going to show you the failure case of when you don't use it. So I'm going to say just use R in front of all your regex patterns. It's so common, and you need that raw string. It's so common that if you might have colleagues that just call it, oh, use the R for regex there, right? But you could do the, well, actually, it means raw. So this character class, it's a string, but after the letter R, so it's a raw string. If we do the brackets A, E, I, O, or U, we're going to match any one of those vowels, any one of those characters. Okay. It's identical to the syntax A, pipe, E, pipe, I, pipe, O, pipe, U. And here the pipe is an or. And what's really, really cool that we can do with the character classes is there's some nice affordances here for ease of use. A-Z is not going to match A character hyphen Z. It's going to match all the lowercase characters A through Z. Same thing with uppercase. Yeah.
You adjust that range like A through M.
Yeah, oh yeah, 100%. We could do A through E. I mean, you could build a card catalog, A through E, F through M. Yeah, absolutely.
Can you then, sorry, can you then, like combine A or something, A through F and then.
Or R.
Yeah, we could do A through M and then 0 through 5. And we could get those numerals and those letters. And if you wanted all letters and all numerals, you would do A through Z, A through capital Z, 0 through 9. And that would catch every alphanumeric.
Text that. Comma or the and.
That's, it's jammed up together. Yeah, A dash Z, capital A dash capital Z, 0 dash 9. Yeah, and you'll get every alphanumeric. So another nice thing to know is if you need to look for meta characters, like the actual literal star, period, question mark, throw those characters in the character class and their special powers go away. And you match those literal characters. There's other ways of matching those literal characters, but this is one of them. So if you are outside of the character class with the square brackets, if you need to match a literal meta character and get its actual character, not its special powers, you'll need to put a backslash in front of it for the escape character. So if we need to define the plus sign and match a plus sign, we would do backslash plus. And this goes back to this idea of a backslash is escaping the normal character, escaping the normal behavior of the next character. So the letter N has the job of being the letter N, but if you escape the letter N to do not its normal job, backslash N is a new line character. Backslash T is the tab character, right? So this idea of escape characters isn't brand new. Y'all have seen this. And yeah, so let's talk about some characters for special sequences. And again, it's okay if you don't, you don't have to do flashcards on this stuff every night, 15 minutes a night, unless you really want to drill your regex, which, that's worth the time. We have this idea of character sequences, and I'll go through this. So the period character, this is the first meta character to wrap our head around. It matches one of any character. Enye, 4, P, Q, whatever, matches one character of any type, of any character, right? Now, we also have a shorthand for the character class 0 through 9, and that shorthand is backslash D. So with backslash D, we're saying, give me any numeral. So 2 characters instead of 1, 2, 3, 4, 5 characters to do the same job. Because of course, computer, there's 2 ways of doing everything, right? Or multiple ways of doing things. We also have this idea of negation with these character sequences. A capital D will be 0 through 9, not. So not 0 through 9. So capital D is matching non-digit characters, and that's equivalent to the character class 0 through 9 with the not operator in front of it. And that caret, I know I just said meta characters are ignored inside of character classes. The caret is a negation operator. And it
outside the class, it starts with, right?
I'm sorry?
Caret, it
Yes.
starts with
Yeah,
outside.
caret is
Caret, it's not.
correct,
Okay, I didn't know.
which increases the amount of opacity and challenge and
Right.
getting our head around this. Caret means starts with the next character outside of the
So
brackets.
if you put your outside the bracket right in front of it, it would mean.
Starts with a numeral.
Anything in there, but inside means not these things. That's
Correct. Yeah, I didn't design the language, but
Okay, I'm glad I know.
yeah, this is one of those things like that difference makes all the world.
Yes.
It means the difference between finding what you're looking for and you getting nothing and not getting an error, right? So this is really what I mean when you've got, you got the regex and you bring that into the shop. I'm not going to say you can write your own ticket with regex, but folks don't want to lose their regex experts, right? \S will match, any space character. And I know that sounds crazy that there's multiple types of white spaces. So white spaces is like a space character, a tab, a soft return, or a hard return, like a new line character. I'm reasonably certain that lowercase s has an uppercase equivalent that's the negation. So anything that's not a space character. And then \W is any alphanumeric. So lowercase w covers any character, any letter, any numeral, and underscore. Why underscore? Underscore is very commonly used in file names. So not every language, but at least in Python, it might pass as alphanumeric, just because it's just so commonly used in file names. That's my understanding. There could be another piece of rationale, maybe because in 1975, somebody at Bell Labs did something and now it's enshrined as an alphanumeric. There might be some crazy lore there.
So it's different from the period, is that just like special characters?
Yeah, period will match anything, a $, the letter P, the letter Q, capitals. The \W will match only alphanumerics and an underscore. So lowercase w is not going to match special characters. So, yeah. And then capital \W is going to match any non-alphanumeric. So that's equivalent to the not operator in front of A through Z, 0 through 9 underscore. You have my compassion right now because I'm showing you two different notations for the same thing, and they're special characters. So it's okay to slow down a little bit when you encounter regex. Slow down, think really methodically. Sometimes I'll write the regex on paper and diagram it out. There are also regex tools out there that are really, really cool and that visually show you the pattern and try to explain that pattern, like regexer. And what's another one? Regex 101. Yeah, regex 101, I think. Yeah. So you've got to pick your regex flavor, but it'll give you explanations of things. So maybe we have 'twas Grillig and the slitty toves did gyre and gimble in the wave. All mimsy were the barrow groves and mome raths out grave, right? If we put was here and we run that, we see that there's a literal match for was. If we see W, any character S, we see was. If we see W period, we see anything, any piece of string that is W and then 2 characters of anything. So we have the first 3 characters of Wabe, and then we have the last 3 of twas. So yeah, I'd bookmark regex 101 because it's nice to be able to get a visual. I see a question from Jen. Yeah, go ahead, Jen.
Sorry, and maybe this is me dumbing it down, but I'm trying to just understand and wrap my head around it. So what you're saying is like when we are using the character class as brackets, that's allowing us to find multiple different characters. Whereas if we use the backslash or the period, and then the other, whatever, D's or S or W's, that's only finding one character. Is that correct? Or can we put multiples with that? With the backslashes?
I mean, we can put multiple of anything. Like if I said, give me the \W, see how this is giving me every single thing that is a letter. But notice how each of the highlights is highlighted. So see how many matches we have. We're matching every single character. So what if I wanted to find 2 alphanumeric characters in a row? That's /W//W. And if I did 3, that's 3 characters in a row. And what if I did a \S, which is a space character? So give me 3 of any alphanumeric and then a space. Now, what if we want this to start with a space? We do space, 3 letters, space. And now we have and, or space and, space did, space and, space the. So we build up these patterns. I'd say start very, very small and start building up your pattern. And look at that explanation. This is why this tool is really nice. It's explaining what's going on. Just make sure you click Python over here, because if you run like Golang or some other languages regex and try to apply that to Python, you're gonna have an impedance mismatch, right? Jen, did that answer your question, or did you have a follow-up maybe?
Yeah, no, I think that's that was part of what I was saying. And then also in that, in looking up, let's say that I want to find, maybe this is not how this is being used, but if I wanted to find all the A's within this string, right? Or this corpus of string.
Letter A. Yeah.
Yeah, just the letter A, right? Could I could still use that WX, correct? Or
Well-
sorry, \W. I'm still trying to figure it out. Is that true or no? Or is it just found it?
If
Yeah.
you want to find the letter A, you just give a pattern of the letter A.
And that's it. Okay.
That's it. And so this
Okay.
is, so what we're doing right here at the language that I want us to adopt here is, this is a literal. I'm literally looking for the letter A, so it's literally looking for lowercase a. If I look for capital A, it's not there. And we can turn on and turn off the case sensitivity. I'll show you all how to do that momentarily. If we're literally looking for the word gyre, we find the word gyre. If you're looking for the pattern gyre and gimbal, see how it matches that whole literal. And so it's kind of in the ish grayed out here, but we start a Python regex string with R, and then we have quotes. And then these 2 modifiers at the end. We don't really need to worry about those right now. The G stands for global, meaning it's not going to find just the first match. It's going to find every match, which is nice. And then M is a multi-line modifier, and that's a nice to have. We'll hit the M modifier kind of later in the notebook. Let me check the. Okay, cool. Yeah, regex 101, pretty impressive project. If we wanted to say, here's a fun one. Give me the letter G, and then I'm going to use a special character. I'm going to cheat and look at my notes. So period is going to match any character, but on its own, it's only matching one character. But if I want to say match any character, however long, we bring in our repetition meta character, star or plus. Star is a 0 or more, and plus is a 1 or more of the previous pattern. So like some of these patterns look to the left, some of these patterns look to the right of what's going on. We need to be aware of that context. But let's see, if I want something, a letter or a pattern that starts with G, and then there's any number, 0 or more of any character, and then a space. Oh, that's greedy. I'm getting ahead of myself. Let's do, starts with G, has any number of any character, ends with E. And now, just the way this is broken out, it's starting with, because I told it to, because I said any character, it's starting with the G at the end of Brillig and going all the way to the end of this. And this behavior is called greedy. I want to build up to greedy versus non-greedy behavior. Let me see if I can, instead of any character, let's say alphanumerics. See how that any character was matching the spaces. So now I'm saying, start with G, give me any letter or number, or we could do a character class in here, like A through Z. So we skip the numbers, and this is saying, give me 0 or more, or give me 1 or more with a plus, and then end with the letter G. End with the letter E, rather. It doesn't take much for this to start feeling like some pretty wild algebra. And it is algebra. I mean, the regular expressions are a type of algebra and pattern matching, but already we have a lot of power and precision with just a couple of characters here. If this part is moving a little fast, that's okay. I was going on a little aside. Don't worry, we're gonna get back to the code in just a second, build up our scaffolding with some more basics. Fred?
If you're using like regex for readability, you like bracket it a certain way, or does that kind of interfere with the function? that you had?
For, when you say readability, do you mean readability of your code?
Yeah, so like, there's that slash notation, like slash W, you kind of bracket that a certain way, or anything like that, or you just put it in the expression. I know like functionally you didn't have to bracket it, but if you're writing it for replicability, would you bracket it?
No, like this A through Z is gonna match A through Z, but if this will not match numerals, the \W will match a numeral or an underscore or a letter. For those of you remote, Fred's question was about readability. Regex is unfortunately not built for readability. So my professional recommendation is comment the crap out of your regex. Even if it's just for you, comment the crap out of your regex. Like plug your regex into an engine like regex 101, copy the explanation and turn that into a big comment line. You will thank yourself in the future. And if you run into somebody else's gnarly regex they didn't comment, use a tool like regex 101 to get the piecemeal explanation. Because it is a different language. It's its own little programming language, its own little mini programming language. And regex goes really deep. I'm attempting, our goal is to try and hit all of the moving pieces of regex. The top like 90% of them. So pretty ambitious. We're gonna get all of those introduced. We'll get the lesson introduced before lunch. So repetition is a big deal. Matching 0 or more of a previous pattern, whatever was to the left of that star, plus matches 1 or more characters. The question mark after a pattern means something's optional, right? If you wanted to, say you were looking for an optional S at the end of a word, you would add S question mark. And we also have this idea of negation. If you use a caret character inside of a character class, the square brackets, you're saying not the thing to the right. Now, just to confuse everybody on planet Earth, if you use a caret outside of a character class, it means starts with the next thing. So if your caret is inside or outside of the character class symbols, it makes all of the difference, right? So if we said, oh, excuse me. If we said the letter A, we find A's. If we put star or caret A, it's asserting for the start of the line. So it's not looking for the start of the word, it's looking for the start of the line. So it's not finding that letter A in there. If I did like capital T, we find that capital T there. Right? However, if we had a character class and we did not A, that would find everything that's not A. So like the context matters for these special characters, for these meta characters. $sign specifies the end. So if we go to something and we say ends with, I've got crap in the way. So $ is an ends with, and \B is a word boundary. So not just a space, but a word boundary. I'll show you what I mean by that. If I say S word boundary, that finds all of the S's at the end of a word. And we could also say, give me one or more of any character that ends with an S. So that, actually, I should do it \W. So this is give me alphanumerics. Give me all the alphanumerics that end with an S right before a space. This is the part of the episode where I say we're going to build up tiny pieces. We might take a little break here, just to come back fresh. The best way to learn this stuff is to experiment with it and to stub your toe a little bit, bounce off the walls. You might have some colorful language about regex. That's okay. It's as long as you're experimenting and bringing your curiosity, you're going to learn. You're going to learn this regex stuff. And then we have this concept of groups with parentheses. And I'll tell you, between pandas and regex, we can do some really powerful stuff with these regex groups with parentheses. Think of parentheses kind of like as math parentheses for groups. And regex goes really, really, really deep. The regex that you see on my screen right now is the regular expression syntax for the HTML specification for matching an email address. I'm not going to diagram that out for y'all. But you see a lot of special characters. You see a lot of question marks for optionality. You see question marks for some groupings. The question mark colon has its own meaning. It's bananas. So are we going to build something this complex in these exercises today? No. And I'm here to tell you, if you need to match regexes for a previously solved problem, right? The world already knows how to match email addresses. So don't reinvent the wheel, right? Just search for regex to match a URL, regex to match an email address. There are, in fact, engineering standards for certain regexes. There's even engineering standards for email headers. So you don't have to reinvent every wheel. But based on your corpus coming in, your corpus might be unique, right? You might have, if you're matching, if you're looking at, I don't know, Star Trek transcripts from some Star Trek enthusiast website, it'll have its own formatting to denote like who when somebody's saying a line versus an action, and you'll have to figure that out and convert that, right? If you're trying to make a corpus. So we will build up. I've got lots and lots of teeny tiny examples here. And what I'd like to do is I want to give y'all a little break. It's great timing. Hydrate, rest your eyes a little bit. Let's take 10. Let's take 10. Not a super long break, but 10 minutes. 10, 12. We'll come, or 11, 12. We'll come back. We'll just call it 12, 12. 11, 12. We'll return. All right, so let's start to crawl before we walk, and let's start to crawl and walk before we run. What I'm going to do is import the regex library, import RE, and then I'm going to pull in pandas because at the end of this notebook, we're going to put those two things together, and you're going to see quite a lot of capability through that. This notebook, in case you didn't see it, you can grab yourself a copy. The link to curl and the command to curl is in the Jemison Slack channel. Copy that, run it in your terminal. That being said, be sure not to just curl random stuff that strangers give you, because curl downloads files, right? It doesn't run them, but it downloads them. So I'm going to give myself an example string here. It's the first line of Hamlet. Two households, both alike in dignity, blah, blah, blah. How to use the search function with the regex library. What this is going to do is we say, hey, regex, call the search function. The very first argument, we want that to be one of your raw strings. That's the pattern. And then the second object is the subject string. That's the language of regex. There's a subject string, then there's a pattern. And what this returns back is something called a match object. And this match object has a couple of pieces of information. It's not just returning a string. So objects are, you've already been working with objects, like a data frame is an object, a list is an object. It's a superset of different types of things. Some pieces of information that we know, we get the span of where there's a match. And what the match was we literally matched the string Verona. Okay, so consider if we were to use the splice syntax on the string, at the span that we're given, we can pull that out, the start and the stop there. If we wanted to look for a couple of strings, like in fair Verona, nothing really changes. We have that literal matching. So literal matching, make sure you get your head around this literal matching. It's more powerful than just substring. It's more powerful than just the in operator, because it's saying, does that exist in there? Now, if based on this, if I had, oh, am I not sharing the screen?
Not right now.
Thank you, thank you. You are a strong advocate for our remote learners. Thank you for saying something. All right, cool. Remember to hit the record button, but there's always an oh, by the way. Cool. So in fair Verona, if I had lowercase in fair Verona here, bumkiss, nothing. What does a search method or return if there's no match? The none type, right? The none type. And we can turn on the case sensitivity or not. I'll show you how to do that in mere seconds. If we search literally for the string Leonardo DiCaprio in those first two lines, there's nothing. If we search for civil with search, we find that first match. But what if you want to find multiple matches? Well, my friends, use find all. And find all is not going to return a list of match objects. It will return a list of the strings that match. So it's a different function. Notice I'm using find all here instead of the match function. So you get back a list of strings. If find all finds bumkiss, nothing at all, you get an empty string. Right, so capital C civil, or an empty list rather, isn't there. We look for Claire Danes with find all, we get an empty list. If we look for uppercase T2, we get one match. If we look for lowercase t2, we get nothing, which begs the question, how do we say, hey, regex, cool it with the case sensitivity? There's an optional third argument that is RE dot capital ignore case. What this is called a flag. There are other flags out there. This is your first regex flag. It's an optional third argument that changes the execution. So if I looked for the uppercase A character in a set of lower cases with ignore case, it finds that, right? So that third argument, re.ignore case. I'm not going to give you any more examples of matching literals because they're just matching literals, right? And again, the one thing I want to remind you about, these two different methods, these two different functions have different functionality. Search finds the first match. Find all is going to find all of the matches and gives you back the string. Our first real meta character that I'm going to show you a little bit more implementation of is the pipe character. This is an OR operation. You have seen the pipe character in such OR operations as NumPy arrays and pandas series. So the pipe character is maybe not in every programming language, but in a lot of languages, it just means OR, right? So we're saying if we wanted to look for gray spelled with an A or gray spelled with an E, we put a pipe character between them. And if I find all of the matches in the string, I can't remember if you spell gray, gray, or gray like gray, or in honor of Bastille Day, if you spell it GRIS, right? Green. So if we wanted to find orange or apple, remember, search returns the first match. Find all, and it's a match object, not the string. Find all is going to give you every string that matches.
I'm just assuming that we're gonna find out that how to use that object that's returned, this match object. It's clear how we've used string object.
Oh, sure.
Excuse me, the list object.
Most of the time, what you're going to do with finding a search is probably slap that in the conditional, right? Because if you put an if in front of that, the null coerces to a false, and the presence of an object is going to coerce to a true.
Okay.
Yeah, that's really the most of the bread and butter. Sure. And like if you have that match object, I'll just say X right here. I'll riff on this a little bit based on Ryan's question, how to use the match object. I'm going to assign that to a variable, and then I can do things like we have other methods like end position, group dictionary. Those might not mean anything right now. You can ask the match object, what was its regular expression that generated that? So yeah, once you assign that match object to a variable, then you have, I don't know, 12, 15 different methods you can run on that. So you'd say, what was the string that we matched? Oh, it was the original string, the subject string. So if like 100 lines after you defined a regex, you could still ask questions about the pattern. Find all is not that powerful. Yeah.
A question on that, Ryan, and maybe I did see it. So if you go down to scan, so let's say you use find all and you find multiple grays like you did in line 19, can you then find the span of all 4 of those grays? Does that make sense?
Not with find all, no.
Okay.
Yeah,
Okay.
is the short answer. Cool. So let's keep building our basic scaffolding here. Our OR operation we can use over and over and over to find all of the vowels. So again, search is going to return the first instance, find all will return every instance. So if we say, hey, and remember that character class syntax is square brackets around the set of characters that you're interested in. So if I wanted to say, give me any uppercase or lowercase vowel, we do square brackets, A, E, I, O. And that's identical to A pipe, E pipe, I pipe, O pipe, U. Again, the curriculum is going to have a lot of examples and some more text to explain pieces. That my notebook here is baby stepping us into these topics here. The part where regex starts to really be able to do more than the built-in string methods really is the meta characters and what meta characters can do for us. Combining meta characters it's compositional in nature, combinatorial even. So let's take a look at a couple of meta characters together. The caret on its own, it starts with the thing to the right, immediately to the right. So this is going to say starts with the letter B. Period means any character, just one of any character. And then star is going to say 0 or more of what's to the left. So when I search for starts with B, has one of any character, and then that repeats over and over and over, we end up matching Bananarama out of that. Now, I'm going to introduce y'all. I accidentally introduced this earlier, this concept of greediness. So if we say starts with the letter B, and then immediately following B, we have any character, and the star says 0 or more. If we say Bananarama pajama and match starts with B, any more, I know it's very serious business, that matches the rest of the string because of a concept called greediness. greediness here means the star character is greedy, meaning that it will match as much as it can. Almost like somebody greedy going to the all-you-can-eat buffet. They're gonna eat as much as they can, match as much as you can. So if I wanted to have a bit more control and precision here than just match any character, because that includes white space, how about if I wanted to say match something that starts with the letter B and then has one or more of any \W. And recall \W is alphanumerics or underscore. And so this little fella is going to match Bananarama, but because space character is not contained in the \W, we don't match pajama. And there's a lot of ways of getting at this, right? We could have used the \W to match alphanumerics, or I could have said another way of getting at this. I'm going to add a new cell here, just so we can have a little more interactivity. If I wanted to say match any number of any character, but go up into a word boundary, \B is that word boundary. And then this is going to get me another way. Oh, no. Why is this not working for me? Probably because the star is that greedy. I might have to go back to say \W instead of the star. There we go. There we go. Okay.
For that example, why do you use the plus instead of the asterisk?
The difference is plus is one or more and star is 0 or more. Which means it doesn't sound like a big difference, but that can make all the difference in the world with regex. So in this case, it didn't really make a difference, right? But in another case, the 0 or more gives you some optionality. Like if I had, I'll give you an example. Let's say our subject string is the word be. Be cool. If we said match one or more, let's see, I'm going to say \W and give me one or more, that means that I have to have something here. So what if I had only the letter B, like letter B, that one or more is not going to match. But if I have the star instead, that's going to match that letter B. That's the difference between the 0 or more repetition. I know it's weird to think of something being 0 repetitions, but it is a repetition character for matching one or more. They're two different tools that are slightly different. Yeah. If you use a period on its own with no repetition characters, that's just one character. So if you have 5 periods in a row, that's 5 of any character in a row. So you can handle your repetition manually. You could say, starts with B and then has one match the next 3 characters of any. So that'll give you Banna. So yeah, you can manually use that. And you can also specify that with \W. You can say, give me any letter or any alphanumeric, but give me 3 of them. So you can do manual repetition with those special sequence characters, the \W, the \D, that kind of stuff. And a little more programmatic way of handling repetition is the curly brace syntax with numbers. We'll cover some of the options with this in just a sec. For right now, I'm going to say starts with the letter or just match B and 3 of any characters. And so this is going to give me BANA. Because B doesn't count for the 3, that bracket 3 is talking about what's to the left of it. Everything is contextual in regex, which makes it look like wizard runes or something crazy. And remember that star is very, very greedy. It's going to capture as much as it can. So in this case, if I only had the star, that we would match Bananarama Pajama. But if I have star space, that space is going to include that space here. Now I'm showing you general patterns. Now, are you doing a bunch of NLP on bananas and pajamas? No, unless you're analyzing transcripts. What I'm trying to bridge this gap here is showing y'all the combination of literal matches along with meta characters helping match. What can this do for you? Well, if you have transcripts that are like Kyle colon or somebody's name colon, you can match that name up until the colon, and then you can identify the author of a transcript and pull that out programmatically. Okay. I don't just want to run all these cells and say, hey, we're done. If we wanted to say starts with, not just find the A, but starts with A and then has find something that starts with A. Well, we don't, the line isn't starting with a letter A here, so we have nothing, right? Now, if I say ban.star, we get BAN matching literally, and then we have any character is the period, and that star is our very greedy friend that says just gobble match everything else that you could possibly match in that string. Vasily, there are 100 ways of doing, I mean, that's a great question. Because computer, and because of like, just, I don't even know what to call it. There's multiple ways of doing the same thing, and that's the way it is. To the best of my knowledge, one regex way is not any faster than another regex way. It's just different notation. Just like you have an infinite way of summing 2 numbers to get the number 10. The same exists in logic, right? If we have commutativity, A plus B is B plus A. If we have commutativity in programming, then we have that same kind of challenge, right? Welcome to programming. I don't know what to tell you. If we say match A and then any character, then we start with the letter A and we match any character. Remember that star is very greedy. Stars can surprise you. The asterisk can surprise you, or even the plus. The plus is also greedy. I'll prove it. Because the plus is saying match 1 or more of what's previous, the plus is just going to keep making matches all the way until the end of the string in most cases. Unless you had something to the right of the plus that tells it chill out, right? So if we say starts with B and then has 0 or more of anything and then a space, we get Bananarama including the space, right? So if you're using the star, you might need to make some sort of termination to capture the end of that. And in this case, maybe we want to say letter B, capture greedily up until the letter A. Now we might think that this grabs Bananarama, but this is going to grab Bananarama Pajama because greedy. Star is greedy, plus is greedy. It's going to match as much as possible. It's not going to match as little as possible, as much as possible. That's what greediness is. If it takes a little while for this to set and to gel, that's okay. You're literally seeing a mini programming language for the first time. So if we say starts with B and then has one or more of any letter, character, or alphanumeric, that's going to terminate and not include the space, right? And we can also use our friend $sign. I'm going to introduce $sign. So this is going to match 0 or more of any character. And that's going to be greedy. But what if I want to say end with JAMA? Well, that ends with JAMA. What about the same thing with RAMA? We only get the banana rama. Not the But again, if you need to dissect a regex, my recommendation is use that regex 101 site. Be sure to click Python, plug the regex in there, your target string in there. It'll give you a little explanation. That's, I mean, imagine building the stuff just from the documentation instead of having an interactive tool like that. \W on its own, again, that's alphanumeric. On its own, that's only going to match one character. But recall, if we manually have some repetition like \W, that gives us 2 alphanumerics. And we can combine these things with the curly braces, and I can say match exactly 4. Now there's some minimum and maximum syntax I'll get into in a little bit, but that'll match 4 of any alphanumeric. If you only want letters, but you don't want numerals and you certainly don't want an underscore, that's the place to use the character class. And the character class way of saying, give me A through Z, lowercase or uppercase is A through Z. If you jam them together next to each other, that's one way of getting around the case sensitivity. And so that matches the word stuff, but because space is not a letter, it doesn't match the space, and then our match ends and terminates that space. Cool. I'm going to pause real quick. I know this is all pretty new stuff. Is the pace okay? Are things too fast? Are things too slow? I'm gonna err on slow. If somebody says it's too, if it's too slow, I'm still gonna err on too slow. But is the pace too fast? Do we have any check-in questions? You'll need to come up for air. Fred?
Could you clarify the plus example real quick? You've seen a lot of star. Can you show me plus in action?
Absolutely, absolutely. Great question. So Fred's question was about using the plus character. So let's say plus meta character. Let me put the definition. Matches 1 or more. So this is greedy. And I'll put this in the notes. Greedy like star. So plus meta character matches 1 or more of the pattern to the left of that plus character. So let's build this out. Let's do an re.search. We're going to do a raw string, an R string here. And I'm going to say, let's match, if I say \W, that's any alphanumeric or underscore, match 1 or more. And then the target string here, we could say, Fred asked a great question. So the W is going to grab numerals, it'll grab underscores, and it's going to grab letters, right? Now the 1 or more means that it's going to grab that whole word Fred. Now, if I were to change the plus to a star, we get the same result here because the star is 0 or more. Now, why would you need 0 or more to have one tool and 1 or more to have another tool? It's one way of having optionality. It's giving you the option. So let me see if I can't take this example with the plus and run with it a little better. Instead of the \W, I'm going to do A through Z. So that's still gonna match Fred. But what if I had 5 Fred here? Or even $ Fred? So this is not gonna match the $. But what if we had, let me see if I can jam this, just take another angle on this. If I say F, lowercase f or uppercase F, 1 or more, that's gonna match lowercase f or uppercase F. So that matches F for Fred, right? But if I have star here, that's gonna match 0 or more. And in this case, I've got to change my target string just a little bit here to illustrate the difference between 0 or 1 or more. Let's see. We'll change the string just a little bit. F Money asked a great question. We find the F in F Money with star. That's matching 0 or more Fs. Let's see, if I put like the any character here, that period. Oh, I'm going down a rabbit hole, Fred.
Sorry.
No. I don't have, oh, maybe I have a crystal clear example next. What if we want to match only letters and numbers, star versus, okay, maybe I have something here in the next example. Because I didn't, yeah, it's optionality, So if I say, give me 0 or more of A through Z, it's gonna match 0 or more. And if you have the plus, let's see, the plus here is going to be 1 or more. So it's kind of hard to think about 0 characters of something. But once you start really getting your head around the algebra, like this kind of pattern matching of regex, it's a different tool. Phillips versus Flathead. And it's really matching 1 or more or 0 or more. So
It's also a search versus a find all, which I think is.
yeah. Find all is going to match everything that matches. And again, you don't need to get all the rules of regex tattooed. But if you're like really wanting to get this stuff, I'd say flashcards and use an interactive tool like regex 101. Phillips and Flathead versus the 0 or 1 or more. I'm wishing right now I had a perfect search string for you. I just don't.
I get it, yeah, pattern.
Run it frequently, it's like. Whether what's the difference between a plus and a star, which like finding something in a string. But finding the word car in a string, whether it's a race car or space car. Does that give you the example?
I don't think so. It means something's optional. Like if you don't find something like yeah. Sit with it, be with it. We'll have some exercises that help you out. Yeah. I'm going to check our chat here. So if you did, Jen's got a question. So if you did the Fred sentence, but with a space beforehand, that kind of shows the difference of 1 and 0.
I kind of played around with it. I can
Yeah.
post the code.
Yeah. Go ahead if you've got something, Jen. I'll ask for your grace, because regex is one of the toughest things that we deliver. So I will ask for y'all's grace. But if you've got an example, that would help. That's showing one or more. The star is also going to be greedy. I think the challenge is that the greediness of both operators makes it confusing.
That was a note, I don't know.
Yeah.
That kind of makes sense to me, but I don't know what it says. It says like the plus or requires at least one character.
Well, yeah.
Star can match none. And for me, thinking about.
Star can match none. That's the 0.
Yeah, okay, for me, thinking about it being none instead of 0, for me,
Let's see. Yeah, star matches none. That's the 0
okay.
or more. So like, let's jam on it a little bit because this is important. I'm not just gonna pull the eject button that says, give me your grace, and then like give up, right? Y'all deserve better than that. Let's jam on this a little bit. If we were to say re.search, give me code, give me F and one or more, so match F and one or more of any character. And then we'll get back to the regular scheduled programming. Let me see if I can't find a great example for y'all. And let's end this with a space character, just so that we terminate that greediness, because I think the greediness is getting in our way of understanding, because both of them are greedy, which means in Jen's example, they're going to match the rest of the string. So we need something terminating, like so F Funny asked a great question. I think I was onto something here. I got to terminate the parentheses. And let's not do any character. Let's do a letter. There we go, an alphanumeric. So A through Z, or a numeric character. That's so weird. Why? Oh, greediness. Oh, it's because I still have a star here. There we go. We're going to match the literal capital F character. Then we're going to say one or more letters or numerals or underscores, then a space character. So notice the one or more is not going to match, does not match F on its own. It's the difference between, like I keep saying one or more versus 0 or more. The 0 could be nothing. So if I were to show the difference here between star and plus, what I'm doing here is I'm saying with the star, I'm saying, and this is where that optionality comes in, match F, then 0 or none, 0 or more of the \W, which is A through Z, A through capital Z, and numerals, that numeral. So check this out. Plus does not find F in F money. Star finds F in F money. Yeah, and I think the challenge here and where I tied my shoelaces together was the greediness of both operators just keeps going till the end of the string, unless we have some sort of termination there.
And that's technically what you're matching is F space, and actually you can see that match. So it's not just the F.
Yeah, because I've got the \F. That's how I'm breaking out of that greediness there.
How would you do it just the F? Because if you take out that /S, you're gonna get the whole sentence, the whole string, correct?
Because of the greediness, yeah.
Unless you just put it, I guess you would just use a whole different regex for that. I'm sorry, I'm taking this demonstration of star and plus.
Yeah.
and asking.
No, this is great. That's why we have this notebook that has more baby steps than the curriculum does. Curriculum is going to be great reference for you. There's no substitute for experiments. There's no substitute for curiosity. So I welcome y'all's curiosity. The greediness takes some time to work around. What we can say here is, to get around that greediness another way, this may be a little premature. I could say, give me, oh, here's a fun one. Instead of the \s, I'm gonna chase the shiny because it's a good question. We could say, give me, not to get around the greediness. Here's another thing. We're saying alphanumeric, curly braces. Remember curly braces, if we put the number 1 in here, that's gonna match, that'll match just one character. Let's see, \W. Oh, because, yeah, no. The \W is not matching the space here. Right, because there's nothing after that. But if I wanted to say, maybe give me up to 4 is ;4. So 4 on its own would force Fred versus Frederick, right? It'd only pull Fred out of Frederick. The 4 here, this is a good opportunity to put in that star. So give me any number. So this will match 0, or it should. Oh, I broke the internet. Awesome. Oh, I can't do both. I can't do both the numbers and the star. So this is matching F, but this same pattern, this is not quite the same thing as star versus plus, but this same pattern here with the ;4 should give me back Fred or the F with that optionality. Y'all are seeing a totally different notation for the first time, and it's a totally different formal language. So this is the kind of stuff, if you want to really love regex, noodle around with this. You put your stories on the TV and noodle around with regex a little bit. Cool. Was this example on the F money with the plus versus the star, was that helpful? Is that helpful more than just to Fred?
It was.
Okay, cool. The hard part is that greediness of both star and plus.
So just looking at it like a little bit online, so is pretty much everything else considered lazy? I'm seeing this word like lazy.
Yeah, lazy and greedy. Y'all have heard lazy before. That's a computer science concept of it doesn't mean like blow off your chores. It means do the computation or do your chores when you need to. Lazy and eager in the computational world. So y'all have seen lazy before. Range a whole bunch of trillion. That did not produce a trillion numbers in memory. That produced a range, which is the capability. It's representing that idea. And we won't realize this range until we loop through it or try to turn it into a list. Like that will realize that execution.
What's the other one? I'm trying to make it just kind of some terms.
Oh, yeah. Lazy and eager. Eager means you've got that stuff in memory and it's going to compute. Some other things that y'all have worked with that are lazy, like range. Do you remember working with the combinations library, the collections library, permutations and combinations? You had to, we were getting combinations of letters and strings and permutations. We've all slept since then, but we had to like write list around the combination. No, it's Python. It was Python library imports before pandas. It's okay, we've all slept since. There's a lot of stuff that's lazy. Yeah, range is the easy example. Range 9999 doesn't produce those numbers in memory until you need them. Greedy. Yeah, greedy and greedy will just keep going. So it's can be tough to reason about greedy operators. To help us with the greedy operators, I give you a little bit of a preview on this, is using the repetition syntax with the curly braces. So \W3 matches the first three alphanumerics. If we want n or more, curly brace number, comma, and that's going to match one or more. So like, this is pretty interesting. This one or more letter character, let me see, so n comma, this would be equivalent to plus, wouldn't it? Let me make sure, yeah. So \W plus means one or more alphanumerics. \W1 curly brace comma means the same thing. Because computer, there's multiple ways of doing the same thing. Cool. So this comma syntax inside of the curlies, you can specify one or more, 10 or more, 8 or more, like that could be helpful maybe for phone numbers that might have 7 or 10 digits. Right?
Put a 0 into the find all of the search, does it like return that thing? It doesn't look like it's 0.
Yeah. I'm sorry. I take that back. Ryan Miller asked a great question. Can you put 0 into the curlies? I confidently gave him the incorrect answer. I was trying to focus on something else at the moment. You are matching the empty strings here because empty strings are 0 length. Yeah. Hey, thanks for dropping by, Maggie. Yeah. And you can provide bounds. Starts and ends with, so 1 to 6 matches. So notice that's finding the 1 to 2, the 2 characters, the 3 characters, the 4 characters. If you need exactly, it's just one number in there. So 1 to 6 character matches, 2 to 6 character matches. Pretty good stuff. And yeah, \W space is the same thing as \W curly 1 comma. All right, we're coming around the bend here. So looking at, so phone numbers get a little bit more complex because we can have area codes, calling codes, stuff like that. Are we on a time thing? Oh man. I hate Thursdays. Like I'd like a long lunch. I'm sure you all do too. Do y'all want to power through?
Yeah, can we get those on the back end?
I've got something this afternoon. I mean, the notebook isn't a super secret, but all right. Y'all have this notebook. I'll give you the highlights. The next section is splitting strings on characters or splitting strings on patterns. We talked about character classes, so that's not new. You can combine character classes with other meta characters. We talked about repetition already, actually, so that's good. The new stuff is groups, and groups are kind of a trip, but it's laid out in here, and this notebook goes into more baby steps than the curriculum does. Here's your end result. You can take really, really gnarly logs like that, or lists of emails, produce patterns. And if you put these are called match groups. If you put your match groups together with re.search, you can produce, folks, lists of dictionaries. And I'll give you 3 guesses what you can do with a list of dictionary. All right. Thanks for tuning in. Y'all have exercise time this afternoon. Read up on this stuff. Have a rock and roll lunch, y'all. Take care.